we get a presentation by Dr. Chongo, and we will be able to interact once all the presentations have been received. Dr. Chongo?
Thank you. All right, good afternoon, ladies and gentlemen. I don't know if we still have excellencies among us. Anyway, ladies and gentlemen. My name is Mawaki Chongo. I am a researcher, consultant. Notably, I teach as assistant professor at Kara University in Togo. And also, I am the founder of Digilexis Consulting, which is a small consultancy business dealing with internet policy, ICT policy, governance, and also management issues, corporate management. Thank you. So I'm going to talk to you about the Internet of Things. It will be just a brief introduction to the notion of Internet of Things. You may have heard of that phrase many times. It's kind of straightforward, Internet of Things. But I remember the first time I heard it, it was a little surprising though, because when you say Internet, you are online, you are in front of a screen, computer, etc. And how would things form something like Internet? So basically, it's about connecting physical objects, sometimes virtual objects, as we heard from the presentation of Dr. Bob Kahn this morning. And mainly regarding physical objects, that is made possible because of the technology of sensor, the miniaturization of the technology, such as chips and sensor that are embedded in objects. It's one of the things that have made the Internet of Things possible. Namely, the phrase came about in 1999 by a British technology pioneer who used it in the context of RFID. RFID is about radio frequency identification system, which maybe is the earlier occurrence of Internet of Things because it has been used quite massively to track goods, transportation and distribution of goods, etc. Namely, in the context of agriculture, but also in terms of just retailers selling and distributing and delivering goods around the world. Okay, there are various definitions, with different, tackles and nuances and perspective on it. Basically, it's based on the definition. Any definition includes some kind of networking technology, the baseline of which is IP networks, internet networks, and the computing capability which enables computation to integrate more and more physical objects. These generate a lot of data, and the devices communicate those data without human intervention, which is a characteristic of what we call Internet of Things. Less human intervention there is, more it's really belongs to that notion of Internet of Things. You might remember, before I get to connectivity models, what I didn't say in my introduction is that my research also is heavily involved in identity management, online digital identity management, but mostly for human beings. So our first premise in digital identity management research and practice circles is that the TCP/IP protocol stack lacks of identity layer, meaning that the TCP/IP was built actually without the identity layer for authenticating or for ascertaining rather the user on the other side of the screen, which leads to a lot of problems. But that was also part of TCP/IP flexibility and modularity and all that. So, in fact, TCP/IP enables the identification of things. I was glad that Bob Kahn stated the same this morning. With the internet, we were already dealing with the Internet of Things, because the actual things that are connected through TCP/IP are computers. Computers in the TCP/IP realm are identified. They have IP addresses, which are unique, so they are well identified. The only problem, the missing link, if you will, is that last chunk that link the device, the computing device, to the user acting on that device. So we were already in the same kind of notion of Internet of Things, even if we didn't call it that way. So with the Internet of Things, what is happening is just that there is an extension of computing capabilities to daily objects, tools, and all sort of items which we did not know as computer previously. So what is happening is that those computing capabilities integrating those objects, we are seeing more and more of those devices becoming computerized, of course. And the human universe is becoming more and more computerized, and human beings will be soon embedded, if they are not already, in a computerized or in a computing universe. So the connectivity models that are used generally in this context of Internet of Things include device-to-device connectivity, device-to-cloud, device-to-gateway, and back-end data sharing. I'll go into some detail regarding each model. So the device-to-device connectivity model is just two devices interacting, if you will, between each other. Like if you act on one, the other one responds in some way. So the basic example here is the light switch and the light bulb. You switch on, the light goes on, and you switch off, and it goes off. There is some, capability, sensor, computation involved in the new generations of switches, which makes it a part of Internet of Things. So that interaction uses either IP networks or Bluetooth, which is a wireless technology, as you know, but there are other protocols or technologies being developed. I have mentioned a couple of them here, Z-Wave and ZigBee. Some of them may be public open source, if you will. Some others may be proprietary. The device-to-cloud model is basically a device that is directly connected to a cloud service, either through cable or through some wireless technology. You can have wired Ethernet or Wi-Fi connecting the device to an IP network and ultimately to the service, to the cloud service. The next one is device-to-gateway. In this case, you're having an infrastructure that is more and more, that's larger, that's getting larger and larger, if you will. The device actually is connected through an application layer gateway to a service, to a cloud service. The typical example of that is when you're wearing, for example, a personal fitness tracker. It needs the application, the base application, which is on your smartphone, and the smartphone relays the data collected from the tracker to the cloud service. Now the last model, the backend data sharing, which is the largest of the models, that kind of enables third-party services to share or to request the user to share their data. So I may be collecting data regarding my fitness and all that, my physical routines, but some other third party, like maybe an insurance company, may request the manufacturer or the vendor of my application to share the data that I have stored in the system. So that may be justified sometime. So, in terms of this model, it's kind of enables more, it makes it more feasible to share with third parties. And sometimes that may be useful for the user. Sometimes that may be just a good business opportunity for the third party, but the user still has that opportunity to say, yes, I want to share it with another system, another service, or no, I don't want to share it. Now let's enumerate a few issue areas regarding the Internet of Things. The main one are security, privacy. I'm not going to go into any detail regarding interoperability and standard. Those are, technical standard development issues, and I think Mr. Bob can touched upon that aspect quite extensively this morning. And the last set of issues are the emerging economy or developmental issues. Now, security. So, as you may have guessed, having issues with security issues, with the internet itself is already something to keep people really busy. But if you are surrounded in your home, in your workplace, etc., by a full array of devices that are computing and sharing data with other devices around the world without necessarily you being aware of what's going on, that may raise some more serious privacy or security issues. Both go together. So the network, the characteristic of networks, like network effect or network power, also apply to these threats and these risks, because you have all those devices that are now in your ecosystem. As soon as one of those devices presents some vulnerability and can be accessed by someone that is not supposed to be there, the whole system becomes more vulnerable. And more you have those entry points to any threats and risks, more vulnerable the system. So the network effect kind of multiplies also the risks. Now the question is, can we, by policy intervention, by human intervention, maybe by design first, and then by policy, can we mitigate, or how can we mitigate those risks? So there's a lot of challenges because, again, we have different set of devices from different vendors, from different manufacturers, and the technologies may be different as well. So there's a need to get some conversation going and to make sure security is taken care of from the get-go. Privacy issues, that relate to the same situation as security. When the data is not secure, or when there's no enough privacy, where privacy is not well managed, well secured, then you are open to security challenges. So regarding privacy, we're talking here about human beings, because all those devices are used by human beings. They surround human beings in their home, in their workplace, etc., and they collect data, plenty of data regarding things that you're doing, things that you that are part of your routine, the kind of movie you watch and the kind of services you subscribe to, etc., etc. So accessing, having the wrong party accessing that data is a serious problem and privacy problem. And the problem is that, again, the devices are supposed to communicate among themselves without human intervention. And combining different sources of data sometimes leads to insights that even the user himself or herself, the data source, is not even aware of. But it can go quite, it can be quite insightful about their way of life and a bunch of things that they do without even noticing it. Legal, regulatory, and right issues. So all of those novelties actually raise serious legal and regulatory challenge. And the data that is collected, of course, you cannot be sure that it will remain in one jurisdiction. And actually, generally, it doesn't, because, you know, we are surrounded by global giants. Google has facilities all over the world, data centers, so does Facebook. So the data flow cross-border. Now the question is, which jurisdiction will apply? You know, different countries have different jurisdictions regarding data protection, and that's a serious challenge. Shall we let the jurisdiction, national jurisdiction, and legal situation as is prevent all the technology, all the innovation that may come out of these novel technologies? So collecting data, of course, it's about delivering service to the user. Not knowing what the user is doing is not an end in itself. It's about developing new services and delivering to the user so that we have, you know, those business will have more and more clients. It's all about economics and competition. But the thing is, some of the data may be detrimental to the user, and some of the use at least of it may be beneficial. So we need to monitor that kind of question and the usage of the data to make sure that the intended objectives, the intended goal and use are the one that is being implemented. We are having also more and more data collected from those devices in legal actions. Now, the question is, do we have the framework, do we have the right framework to make sure that when the data is used as evidence, as legal evidence in courts, it's really properly used and it's really consistent with legal principles. Now, regarding developmental issues, of course, we have a lot of potential application, and it's not only useful for developed countries. More there are needs, more opportunities there will be to use this kind of technology as well. So the needs are shaped by, the opportunities are shaped by the needs, which means that developing countries will have also a lot of room for these technologies. Already we can see some application in agriculture, in environmental issues like waste management, health issues, health delivery needs, and also the food chain management, the delivery of agricultural produce around the world, which has been dubbed smart agriculture, as you can see on the slides. So to conclude, as I said, the definition, you can have different sort of definition, but the basic things is that there's sensors are involved. IP networks is the baseline for communication, and devices, daily items are being more and more computerized to be able to exchange data, to communicate among themselves without human intervention. The connectivity model, we've been at length on that. And the issue areas include security, privacy, that's a very high stake issues, and then how the legal framework, the policy can keep up with these technology, these innovations, and also development opportunities. One last word I would say regarding those issues is that in Africa, in developing countries, we already have challenges with the internet, access to the internet, to the plain internet. The question is, if we are connecting, we are going to connect all those devices, is this going to be a burden on our infrastructure, telecom, ICT infrastructure, internet infrastructure, and resources that we have? And how can we avoid that kind of situation? So policymakers will need to give this a thoughtful consideration to be able to create the appropriate policy framework to enable the use of this technology in a good way, in a way that really foster development while not taking away the meager resources, network resources that we already have, we are struggling with. Thank you.